Today what we're going to do is we're going to look at reading just another type of graph. And these are called travel graphs. And they're very, very easy to read. There are just a couple of areas where you might have a problem reading them if you make the wrong assumptions. Okay? Now, because what we're going to be doing is we're going to be looking at simply how far someone or something, because there's one where there's a cat, of course.
Cat?
Yes, of course. Traveled over time.
My cat doesn't move.
Okay? All right. So, in other words, let's say that you were walking to school today. All right?
Unrealistic.
Now, do you always walk at exactly the same pace?
Yes. No. Normally it's really fast.
Most people don't walk exactly the same pace.
Yeah.
What happens if you guys, come on. What happens if you meet a friend not coming along? What do you
Run up to them and scream in the air.
So you may travel a little faster until you get closer, and then what?
You stop and talk.
You stop and talk, right? So all of those things, guys, all of those things affect the amount of time it would take you to travel, right? So we travel at different speeds, different rates, okay?
What if some people do travel at the same because it doesn't matter
Some-
if they see a friend
Right.
because they don't care about the friend.
That's fine. Well, sometimes that happens. And so the rate is just the speed of travel. You've heard of the word rate before. It just means how fast you're going. Now, a couple of things. When you're looking at rate on a graph, rate is the same thing as the gradient.
Wait,
Because if it's steeper, very steep, what does that tell you about a gradient? That it's higher, going up, right? What if it's very low? That means you're going, well, if it's not, it's still going up, but it's very slow. That means you're going slowly, right? What if it's completely flat?
then it's not going anywhere.
Then you're not going anywhere. What if you're going down?
You're going back down.
That means you're going backwards, right? So that's not going to happen with time, is it? Okay? You can't go backwards in time. So you could be going up very steeply, you could be going very slowly, or you can be going, the graph could be flat at which you're not going anywhere at all.
But what if you
Makes
do
sense?
go backwards? Like if you see a friend behind you and you run back to them.
Well, that doesn't reverse time, that only adds to your time, right?
Oh, okay.
Right? So it doesn't reverse the time. Is it relevant to this?
Yes, it is.
Okay, yes.
So travel graphs are they only to measure?
Distance over time. Uh-huh.
Is that the only thing it is?
That's all we're going to be using
Are there
for.
other like graphs that are for particular things like that?
Oh, there are, but all we're going to look at are these travel graphs. Okay? So, let's go to our education. All right, here we go. So, I don't think I've ever seen a penguin carrying a briefcase, but oh well. Top hat, yeah, but not a briefcase.
She's my son.
So, as it's moving, the movements that you take when you're traveling somewhere can be displayed on what's called a travel graph, right? So do you think these kinds of graphs are always going to be linear, which means a straight line? No, if it were linear, that means you went at exactly the same speed the whole time, right? In usual, they're going to be kind of a jagged line because you might not go the same speed all the time. Do you agree? Excellent. And if you look at the graph, the y-axis always tells what thing? What does it say up there? Distance. Excellent. And the x-axis is the time. And the time can be measured in different units. That was very odd. The chair just... Come back. Shh. Okay. So, travel graphs are often called motion graphs because they track your movements, right? Or your motion. Okay. Also, remember, though, that reading a graph, remember when we did the reading graph section, your answer, ladies, your answer is worthless if it doesn't have what? Units. Excellent. And pay attention to the units because distance can be meters, miles, kilometers. Time can be seconds, minutes, hours. So make sure you're very careful about watching your units. Okay? So make sure again, there we go, talking about our units. All right? So, here the penguin says it takes him 10 minutes to walk to work, which is 800 meters from his home. So we could graph that.
Can you be a girl?
So, she, yes, okay, fine with me. All right, in the SMART lesson, you're going to get exercise the skills you looked at to make some travel grids. So you need to know about plotting, reading, and analyzing linear graphs, right? But these are not going to be linear because they're often not in a straight line. We need to be able to find the gradient, which means how high it is, the slope, and we need to find the y-intercept and the equation of a line, because you can still represent these things as equations in some cases. All right, so all right, I have no idea why, but you're probably not a dinosaur, flying fish, or a penguin working in Antarctica.
I am.
Probably, right? They're your neighbors. Okay.
I'm a penguin working with a giant.
So let's talk about a more relevant situation, Dave's trip to school. So look at Dave's trip to school. Is that line, his trip to school is represented by the green line. Is that line a straight line?
No.
Not at all, right? Because he's taking the school bus. Guys, he's taking the school bus. And what do you know about buses?
They stop.
They stop, don't they? They also, sometimes they'll be traveling on roads where they can go very
Slow.
fast or sometimes very slow. Either way, right? Okay? So, all right, guys.
We know the most way.
All right, so here we go. So, as you travel along, he's going in some distance. In this case, what distance? How is this distance measured and what kind of units?
And kilometers.
Kilometers, excellent. And the time units they're using?
Minutes.
Minutes. So kilometers and minutes. So here's another one. Rebecca takes the bus every morning. The distance is measured in kilometer and the time is measured in minutes. Okay? So there's a graph of her time. All right? So let's look at the information and consider how far did she have to go to get to school? How can you tell which point represents how far she had to travel to get to school?
The point at the end of the line.
At the end of the line, right? Because that's where you stop traveling. The point where you stop traveling is the point where you arrived at your destination. So right there, yeah?
Something bad happened.
And so, can we determine then, from reading that point, remember, X and Y, you're just reading the points, can you tell me then, how long in minutes did it take for her to get to school? 12 minutes, right? So you just read down to the minutes. And how far was her trip?
10 kilometers.
10 kilometers. Now, don't think that because the line went wonky that she was going further than 10 kilometers, because that means that sometimes she went faster and sometimes she went slower. Okay? And we're just going to look at a couple of things here.